This is a video for the introduction to chapter 6, part 1 on angles and parallel lines. We first need to understand what some of these terms are. So the following information can also be found in your textbook. So the very first term that we will be looking at is called a point. So a point just looks like this, just a dot. And there are two things that we will use to describe this point. First is that a point always has a position. It is somewhere in space. The next description we have is that it has no size. It is infinitely small. So we use a dot to illustrate where in space it is. Now in the second question, we have to know the differences between a line and a line segment. So they sound very similar, but for a line, it has an infinite number of points. So if it is infinite number of points, it means that a line stretches forever and ever, and it never stops. This is different from a line segment. A segment indicates that it is just a portion of a line. So this line segment has a fixed length as compared to a line that has infinite number of points, meaning it is infinitely long. The next difference that we have between a line and a line segment is that for a line, it can be straight or it can be curved. So either a straight line or a curve. These are both lines, and they both stretch to infinity. Whereas for a line segment, we will only be referring to part of a straight line between and including two endpoints. So this over here will be an example of a line segment known as OA, starting from O, ending at A. So this O over here and this A, they are known as the two endpoints. The next term that we will have to learn is known as a ray. Just like our light ray, the rays from the sun, they all start from somewhere and they travel continuously in one direction. So a ray is simply a part of a line over here. Remember, a line is infinitely long. It stretches all the way. But for a ray, it has one end point. So over here, this is known as the end point. And on the other end, we have an arrowhead. This is our arrowhead to indicate that it can go on and on forever and ever. Finally, to describe a plane is a flat surface. A plane has no thickness. So you can think of a plane as a very thin piece of paper. Okay, but a piece of paper has thickness. It is very small. Now this plane over here has no thickness. It is infinitely thin, and it is two-dimensional. Next, we'll be looking at types of angles. The following information can also be found in your textbook, page 149. So these are the terms that we need to be familiar with. Okay, so first, we have this particular angle over here. We read this angle here as AOB. So the angle AOB is known as an acute angle. This is the name for the angle AOB. So acute means that the angle is less than 90 degrees. Okay, next, so we are done with the first one already. The next angle we need to be familiar with is a right angle. So this is angle PQR. Over here, this angle is a right angle. Reason, angle PQR is 90 degrees. Next, we have angle ZOY. So this is the angle we are referring to. It is known as an obtuse angle. The reason is because angle ZOY is between 90 degrees and 180 degrees. Next, angle STU. Now angle STU over here can refer to either this angle on the inside, or it can refer to this angle on the outside. Because it is already drawn for us that they are interested in the angle outside, we will not be considering the smaller angle, okay, which over here, this smaller angle is known as a obtuse angle STU, because it is greater than 90 degrees but less than 180 degrees. Now, in this particular question, they are interested in this outside angle, which is bigger than obtuse angle. It is known as a reflex angle. This is known as reflex angle STU. Reason: angle is between 180 degrees and 360 degrees. So we know from these three that acute is going to be the smallest, it is less than 90, followed by obtuse, which is between 90 and 180, followed by the largest, which is a reflex angle of between 180 and 360 degrees. The last one over here, COD, it falls on a straight line. We just call it a straight angle. So the reason is because the angle COD is 180 degrees. Now please attempt question 2 by yourself using a protractor to draw the following angles. The next part is special angles. The following information is found in our textbook page 150. Now if I have two angles, when added up, they give us 90 degrees. These are known as complementary angles. Right, so it is spelled this way, complementary. So let's take a look at question 3 first. Find the complementary angle for each of the following angles. So if one of the angle is 20 degrees, what is the other angle when added to 20 degrees gives us a sum of 90 degrees? That has to be 70 degrees. So we say that 70 degrees is the complementary of 20 degrees. And over here for part 2, the complementary angle for 44 degrees will be 46 degrees, because when we add them up, there is a total of 90 degrees. Next, if the sum of two angles is 180 degrees, then the two angles are called supplementary, as shown over here. So please attempt question 4 by yourself. Please also do the same for question 5. Okay, the next part is very crucial for your presentation. Often we will need to make use of calculations to find unknown angles, and we need to use some properties of angles in order to help us. So you have learned in primary school that the angles on a straight line, they will add up to be 180 degrees. So in this case over here, we call it as adjacent angles on a straight line. When we say adjacent angles on a straight line, we are referring to angle A plus angle B plus angle C gives us a total of 180 degrees. Okay, the next property is the sum of angles at all the angles at the point is 360 degrees. So here we have A plus B plus C will now give us 360 degrees. And we will quote it as the abbreviation as a reason, angles at a point. The third property we have over here is that vertically opposite angles are equal. So in this case, a pair of vertically opposite angles will be A and B. They're vertically opposite each other. So we say that angle A equals to angle B. Similarly, angle X and angle Y, they are vertically opposite each other. X is now equals to Y. The abbreviation that we will write will be vertically opposite angles. We will now illustrate how we can use these properties to help us in answering and finding unknown angles. So moving on to question 7a, we have to find the unknown angle Y. We see that Y, 80 degrees, and another Y, they are adjacent angles, they are side by side, and they all lie on a straight line. So we will be writing an equation, Y plus 80 degrees plus Y gives us a total of 180 degrees because they lie on a straight line, but we need to quote the reason. So we write in brackets at the side, adjacent angles on a straight line. No marks will be awarded if this reason is missing. It is important that you include this. So from here on, continue to solve as per normal. 2y will now be 100 degrees, y will be 50 degrees. Please do part B on your own. I will now illustrate one last example for part C. There are a few angles over here that are unknowns. There are a few unknown values. So we've got x over here. This is another same x. And here we have an angle y. We can see that there are a few pairs of adjacent angles on a straight line. So we know that 7x minus 20 plus 3x should give us 180 degrees. We know that 7x minus 20 plus this unknown angle will also give us 180 degrees. Similarly, for this angle plus y, still 180. And finally, the sum of these two angles will also be 180 degrees. We also know that there are two pairs of vertically opposite angles, meaning 7x minus 20 will be the same as y. Finally, 3x over here will also be equal to this unknown because they are vertically opposite. So first, I'll be making use of these two pairs of opposite angles. Okay, I would like to call this angle over here, let's call it angle A. This symbol represents angle. So we say that angle A is equals to 3x. Reason, vertically opposite angles. So now I can replace A over here with 3x. Next, I will compare these two values. 3x plus 7x minus 20. Okay, over here it is in degrees. It gives us a total of 180 degrees. The reason will be adjacent angles on a straight line. Every time you use a property, you have to write down the reasons. So we're now going to expand this. It is a positive in front of the bracket, so all the signs inside do not change. 3x plus 7x minus 20 degrees gives us a total of 180 degrees. Continue to solve for the value of x and continue to solve for the value of y. And also complete part D by yourself.